Hello and welcome to the Artificial Intelligence-enabled Power Supplier Recommendation System. This application has been developed by Team Thor using the concepts learned at the National University of Singapore, Institute of Systems Science course in Machine Reasoning. We have broken down the presentation into the following parts. First, we will talk about the overall project goal, then the knowledge acquisition and representation methodology. We then show the system architecture used, the inference engine setup, and finally we will show the user interface. The open electricity market has been gradually opened for consumers. The goal of the project is to provide recommendations to help a user choose from the multiple plans available in the market. This is based on the demographics of the user, domain knowledge of the team, and preferences determined from a survey. The first step is to acquire data for building the knowledge base. The existing plan details of all the service providers is recorded. The data from the user survey was analyzed for insights, and one team member provided insights into trends of oil and gas prices. The data from each plan is made into a template in clips. The information from the survey is analyzed for insights into user demographics and preferences. This is in turn used to derive the different certainty factors. The historical trends of gas prices is used to estimate price projections. The main application is coded in Python, and can be accessed through a mobile or desktop. The rules engine is developed in clips. This comprises the knowledge base, the working memory, and conflict resolution mechanism. Data management module is implemented in SQLite. The engine first filters out the plans which do not meet specific requirements. The rules are then fired using all the certainty factors. A normalized score is developed for the estimated cost of user for each plan. These two are then combined to provide a score for each plan before ranking. Now we shall go through a user demo of the recommender system. On launching the application, click on How does it work to understand how the open electricity market works. This is especially useful for users who have no awareness of the new regulations. Show Me provides an idea of how users could save by changing their electricity provider, and some more information of the rollout of the plans in different neighborhoods. Once the user has an idea, she can click on Help Me choose to select a suitable electricity provider. The first part is user profile. The user is asked to enter the type of the residence where user lives, the household income category, whether the place the user lives in is rented or owned. The user also has to enter a risk preference, whether he or she is risk adverse or a risk taker. The next part is user preferences. Whether the user would like a combined bill for utilities or separate ones. If they are okay with paying a separate security deposit for electricity. And whether incentives and reliability of the electricity provider are important factors in their final consideration. The user can specify if there are any other points he or she would like to consider. This will form part of notes for future updates. Now the user can click on Finish to view results. This shows the top 3 plans from the providers based on the user profile and the preferences. The user can scroll down the plans to get more details of each plan, such as the type of price plan, fixed or variable, cost per unit, registration charges, late payment charges, early termination charges, security deposit. That brings us to the end of the presentation. This is a first step in this direction, and over time, this will get smarter with more insights into customer preferences and behavior. Thank you.